Alright, in this video we're going to talk about solving linear equations. And solving equations in general has generated just a tremendous amount of mathematical research. So it's unfortunately not one of those things that you can always just say do this, this, and this and you'll get an answer. Depending on the type of equation you have, things can be pretty tedious and pretty difficult. But we're going to talk about one of the most fundamental cases in this video. A linear equation is basically where you have a variable, and almost always you'll just see x to the first power, and there's going to be an equal sign, hence the equation, in there somewhere, and just numbers floating around as well. So what we're trying to do is figure out what value, if any, we can substitute in for x, so that on the left side, when we do the arithmetic, we'll get the exact same thing as on the right side. So in this case, it's probably pretty easy to guess that x equals 2, but the point of these problems is you want to learn the mechanics on how you go about doing the problem. Because when you can't guess the solution, you'll still have these mechanical, algebraic ways to go about solving the problem. A key thing to remember, and this is what used to help me, at the end of the problem, you're basically just trying to get x by itself on one side. So to do that, recall that addition and subtraction undo each other, multiplication and division undo each other. So for example, in this problem, I'm adding 2. To get rid of that, I'm going to subtract 2, and you have to do it from both sides. So the 2's will cancel out, and 4 minus 2, again, is going to give us x equals 2, which we said was our solution in the very first place. Let's do some more of these. Suppose I have 3x plus 4 equals 17. Okay, so in this problem, it may be a little harder to guess what x is, what value it should be. But the idea is we still can use these basic algebraic rules to help us get a solution. So in my head, again, I'm trying to get the x by myself. The first thing I'll do is anything that doesn't have an x attached to it, I'll move that to the other side. So I can subtract 4 from both sides. I'll be left with 3x on the left side. 17 minus 4 is 13. And now, again, I want to get the x by itself, but notice it's being multiplied by 3. Well, to undo multiplication, I do division. If you divide one side, you have to divide the other side as well. The 3's will cancel out, leaving you with just x equals, well, in this case, 13 over 3. So not a nice whole number, but hey, that's okay. There's no rule that says equations, the solutions have to be whole numbers. So let's keep on doing some more of these basic linear equations. Suppose I have 5 times 2 plus x equals 3 times 4 minus x. So again, the basic idea, what I'm going to do in this case is I'm going to get my x's all on one side, and then I'm going to basically divide by whatever coefficients left. So as a general rule, the first thing you'll do in these problems is get rid of the parentheses. So recall I've got to distribute 5 times 2, and then I'll take the 5 times the positive x. 5 times 2 is 10. And then 5 times positive x, well, I'll just get plus 5x. On the right side, I'm going to get 3 times 4, which is 12. I'll get 3 times negative x, and again, a positive times a negative is a negative. 3 times x is 3x. And now I'm going to get my x's on the same side. So I could either move the x's to the right side, or I could move the x's to the left side. I'm going to move the x's to the left side. So I'm going to add 3x to both sides. So I'll have 10 plus 8x. And now the x's are gone on the right. I just have positive 12 hanging out. And again, my goal is to get x by itself. Well, there's a plus 10 hanging out. I'll subtract 10. Subtract 10. The 10's again cancel out. I'm left with 8x equals 12 minus 10, which is 2. And again, now I'm multiplying by 8. To undo multiplication, I'll simply do division. So I divide by 8, divide by 8. I'll get x equals 2 over 8, which I can reduce down to 1 over 4. And that will be my solution in this problem. Okay, so again, the basic idea, get rid of parentheses, move your x's to one side, move the numbers to the other side. If there's a coefficient on the x term, which means it's either being multiplied or divided by a number, simply get rid of that number. Alright, let's do a more complicated example. Suppose I have x divided by 2 times 4 plus, I want to be a little careful here to make sure our equations stay linear, 4 plus 8 equals 5 times, let's make it x over 4 plus 3. Okay, so again, I've got a linear equation. I do have fractions floating around, but that's okay. I could distribute the x over 2 to both terms, but instead, since I see something in the parentheses that I can combine, I'm just going to combine that straight away. So 4 plus 8 is 12. I can't combine the things in the parentheses here, so I am going to multiply. And recall, you can think about 5 as being 5 over 1. So when I multiply by the first fraction, I'll get 5x. 1 times 4 is 4. And again, 5 times positive 3 is just going to be a plus 15. And again, if I multiply on the right side, I can think about 12 as being 12 over 1. I'm not going to do anything on the right side just yet. And when you multiply straight across, you'll get 12x divided by 2. But remember, you can cancel here. 2 will go into 12. 2 will go into 2 one time. 2 will go into 12 6 times. So if I multiply in the numerator, I'll get 6x divided by 1. But anything divided by 1 is just itself. And I've got, I could even write this as 5/4 x plus 15. And now I'm going to use this basic idea of getting the x's on the same side. So I'm going to subtract 5 over 4x from both sides. So 5 over 4x, 5 over 4x. Sorry for squeezing it in there a little bit. And I'm just going to write it. I'll get 6x minus 5 over 4x. That's going to equal 15 on the right side. It's a little sloppy here. Sorry about that. But now I've got fractions floating around. So I can write 6 as 6 over 1x minus 5 over 4x equals 15. And here I have to get common denominators. Well, I see a 4 here and a 1 down here. If I just had a 4 here, I could do the arithmetic across the numerator. So I'm going to multiply top and bottom of my first term by a 4. 4 times 6 is 24. 4 times 1 is 4. X minus 5 over 4x, that equals 15. And again, I have like terms. I've got an x to the first and an x to the first. I've got common denominators, so I can just do the arithmetic across the top. you can think about this as being 24x minus 5x. Well, 24 minus 5, that's going to give us 19x. Or you could just kind of write it off to the side. You'll get 19 over 4x equals 15. And now I've almost got the solution to my problem. I want the x by itself. So I could divide both sides by 19/4. An equivalent way is to multiply the left side by 4 over 19. But if I do it to the left side, you've got to do it to the right side as well. So 4 over 19. Well, the 4's will cancel out, the 19's will cancel out, and I'm left with just x on the left side. And on the right side, you can think about this as being 15 over 1. 15 times 4, well, let's see, 15 times 2 is 30. So if I double that again, I'll get 60. 1 times 19 simply is 19. And you could think, do I need to reduce this fraction? But if you try to factor 19, recall that 19 is a prime number. So you really can't break this number down any further. You could make it into a mixed number. In general, most math classes, at the beginning in algebra, they may have you do it just to practice, but typically it's not something that's important. Just leave it in fractional form. You could put it into a calculator to get a decimal form, but for me, at this point, I would be happy. I've got x all by himself. I've got a number on the right side, and I'm now finished. So again, the basic idea, get the x's on one side. Basically, you'll get all the numbers on the other side, multiply or divide by what's left, and that will be your solution. So I hope these examples help. Again, they're not meant to be, it's not going to cover every possible example out there, but just to give you some basic intuition on solving linear equations. They're certainly the most easy type of equations to solve. Again, solving equations can get pretty tedious in general, but hopefully these examples will help you make help make sense out of it. If you follow this procedure, for the most part, you shouldn't run into too many difficulties other than just, the basic arithmetic problems. So I hope these examples help.